Greetings YouTube! How is everyone? Homegrown Big coming at you with a little bit of science for the week. Um, this is the first part of a couple of videos that I'm going to do on the human gut and microbiome. It is by no means comprehensive. I'm not doing a survey of hundreds of papers. I'm looking at specific papers and opening up some ideas that might trigger some thoughts for you and kind of push you into your own research and readings to become more familiar with what it is to be human and how we are versus other animals in the animal kingdom. So this paper I thought was very interesting because it's the evolution of stomach acidity and its relevance to the human microbiome, and I will follow up later on looking more in depth with the human microbiome. And I thought it was really interesting because one of the most common arguments for veganism or for plant-based or vegetarian diets is that humans are either herbivores or frugivores, and our stomach acidity does not match that of carnivores or omnivores, and our stomach pieces and parts, the whole digestive tract, also does not reflect that of either omnivores or carnivores. Let's take a look at this and see what this research did. Okay, to begin with, this paper is open access, so you can find it and download it and read it for yourself, and I highly recommend it for anybody who's interested in human evolution, diet, all these kind of things. This is a pretty easy read, and I think you'll find it interesting. I like this paper because it's newer, came out just 2 years ago. They did a systematic review of papers out there regarding this type of science of stomach acidity and the human microbiome, and their hypothesis was that stomach acidity filters out microbial colonization in the digestive tract. And I think this is interesting because so many people have argued that stomach acidity is just for digesting certain foods, and that's not where the science is really at this time and day. That could change in the future. That's the nature of science. It's not a body of knowledge, it's a way of thinking and then testing our hypotheses and then coming to consensus. So their hypothesis was, as I stated, that that stomach acidity is really used as a filtering mechanism for microbes going into the body, and that species that have, for example, are scavengers that eat carrion, like vultures and eagles and dogs and whatnot, would have a higher level of acidity because they're eating putrefying flesh. And then conversely, herbivores would have the lowest acidity because they have the least exposure to possible pathogens. And let's take a look at their methods for doing this. Okay, so before we move on into their findings, I wanted to take a look at this one point because I think it's a critical detail that everyone should consider. So they say here, early studies of the human gut microbiome suggested that gut colonization was stochastic and transitory, and that microbiomes at any particular moment was strongly influenced by recent colonists. This pattern, if general, would have suggested a modest role for human stomach in modulating the composition of intestines. However, recent research in gastric health suggests that the pH environment of simple stomached vertebrates serves as a more prominent function as an ecological filter through its acidity of killing microbial taxa that would otherwise colonize them. This can have some implication for changing diets. And the next thing in thinking about that too is that because maintaining an acidic pH environment is costly, acidic stomach should be present primarily in those cases where it's adaptive. So it was selected for through evolution. and where it was adaptive in a recent ancestor. The cost of stomach acidity is twofold. So, on a biochemical level, the host must invest a significant energy for both acid production and protecting the stomach from acid-related damage. So keep those in mind as we move on. Okay, now taking this and moving a step further into herbivores, they're kind of at the opposite extreme. Specialized herbivores in which stomach morphology is derived to include an alkaline chamber, forestomach or pre-saccus, that house microbes critical for fermenting a plant diet. And, you know, if they had acidic stomachs in any way, it would remove those microbes that aid them in digesting plant materials. It would remove those that aid them in digesting plant materials. Okay, moving on. So the research group here took a taxonomic sweep across mammals and birds, and they made a really huge chart here that I'm going to have to toggle back and forth between. And they made a point to say that they were kind of surprised in the research of trying to put this together, how little research had been done, and how it's kind of this expanding area of research. So I think a lot of this data that we see here will be revised in the future, and we can revisit it at another time. But this is where we're at right here and now for today. So it's a pretty big chart, and I'll have to toggle through a couple of screens here, so bear with me. The first thing that I want to point out is the black rectangle with Homo sapiens, humans. And their data showed that the stomach acidity for humans averaged out to be 1.5, which is extremely low. And so low that it's almost as low as it can get. So moving on from there, let's look at, if you look at the things that I have underlined in red, these are pH values that are around 1.5, so close to ours. And you will see that they are either carnivores or scavengers. If you look at the omnivores, which I have highlighted in pink, which are primates, which would be distant relatives of humans, they all tend to be between 2 and 3.7, and 3 of those are considered omnivore primates. So not even primary frugivore primates, but omnivore primates. And then if you look at the green rectangle that I have, I just wanted to point out a few herbivores, and some of them are hindgut and some of them are foregut, so they have a little bit different physiology there, and they range from 3 up to 7.4, and the foregut fermenters have the most alkaline stomach acidity. So let's move on to the next screen and take a little closer look there as well. Okay, here again I've underlined in red species that have stomach acidity close to ours, and they are all birds and they're all between 1 and 1.5, and most of them are either carnivores or scavengers. If you look above, again, I've green boxed in herbivores of various types, and they are between 4 and again 7. Then if you look up just a little bit above, you can see dog and cat. And you would think that dogs or cats, which are, carnivores, scavengers, that they would have a much lower pH. However, their pH is around 3.6 to 4.5. This is a really interesting finding. This paper opened up my eyes to so much thinking around this whole idea, and the authors of the paper really felt that this showed that humans were for some period heavy scavengers, at the very least when it was selected for. I wondered why they hadn't explored more of the idea of, yes, certainly I'm sure at some point along the way humans were scavengers, but we also learned how to bury animal products and we stored animal products probably for long periods because we hunted large animals, and what that meant for the kind of microbial content of things that we were eating, and how it may have selected for us to restrict some of the things we might have been exposed to. So I wanted to just take a quick look at the digestive tract, and I'm actually not going to go too deep into this because I'm more focused on stomach acidity and then microbial communities, but they did the stomach pH of the entire tract versus the concentrate of in stomach, and then they placed that against other taxa. And here's where we kind of fell according to these authors. Obligate scavengers really stayed low throughout their tract, then other types of scavengers, and then generalist carnivore, and then here they call humans kind of generalist omnivores because we eat everything, and then bat and elephant and then monkey. And the letters on this represent significant findings. So pretty interesting. There's a lot of arguments going around about how is our digestive tract, what's the size of the stomach versus small intestines versus large intestines, and what it all means. So I just want to dip into some other research really quickly and to have a little bit of a conversation about that for our consideration. Okay, I want to delve into Katherine Milton's research. You can find her online. She has a lot of her papers open access right off her website. Really interesting stuff. She's a primate ecologist, and I wanted to look at her research because she is commonly cited by raw vegans and fruitarians as the reason why humans should be eating a fruit-based diet. And she has written some papers where she promotes the idea that humans should eat more fruit and more vegetables because of our evolutionary past. But what I find is interesting is that people don't, in that argument, bring up her later research where she goes into arguments for why humans evolved with meat eating. So that's interesting. But she did this, and this is older research, and I'm pretty sure that there's probably better research coming out and available to us now. But I still think that this is a valid inquiry in the way that she did this, and a good look at, are our guts really like our nearest primate relatives? And is that a good justification for how we should eat? And she looked at a number of different types of apes. So not monkeys, but apes, our nearest relatives in our little family cluster. And pretty interesting, if you look where I have the red arrows here, these are human attributes. And you can see that we have an enormous small intestine compared to our ape family. And we have very small cecums, and we have very small colons in comparison to our ape family. And this shows that we evolved into a different type of ape. Our stomach, our intestines, our cecum and colon are no longer so ape-like, if you want to call it that, ape-like, like our other ancestors. Okay, here we just wrap this up with just a little bit of research from Daniel Lieberman. Now, if you've never read his research, he is a human evolutionary biomechanics researcher. And if you love your feet, go read his research. Really fascinating stuff. He looks at the biomechanics and the evolution of humans. And in general, he's just an enthusiast about human evolution. So this paper he published, this is kind of a new hypothesis. And it's really kind of stirring up some thought in the human evolution research genre. I think it's fascinating. But let's take a look at this. He says that multiple lines of evidence indicate that the proto-human ancestors consumed lots of mechanically demanding plant foods. So just like I've said before in previous videos, lots of foraging, lots of chewing, and anybody who's been a raw vegan who sat down to their dinner salad knows that it takes a good like 80 minutes, 90 minutes to try to finish a meal there. Um, Anyhow, and probably resembled great apes spending a substantial portion of the day feeding and chewing, approximately an order of magnitude more than non-industrial humans. And then as we evolved, there's just this huge jump into the Homo lineage where Homo erectus suddenly had this really shrunken down face and teeth, and they've been trying to figure out why that is. The new hominids had much less bite force, and that doesn't make a lot of sense when considering we don't have record of fire being used until like 500,000 years ago. So scientists have been really trying to figure out what's going on with that. And he suggests here that humans learning to make knives and napping to cut and to chop up and to make meat chewing or just even tubers or whatever else easier to use through cutting, and then having to actually use less energy through chewing and less energy through digestion. And you know, it takes a lot of work to break things down in our body, and if you can do that very quickly and mechanically with some tools, how much of an energy savings that is, and how that could alter our physiology both mechanically and in our stomachs. So that's a nice way to wrap this up, and all of that is going to be changing and altering our microbiome as well, and that'll be the next video. Check out his research, check out all this research, really fun stuff to read. Let me know your thoughts, feedback, questions, comments, and add in anything else that you might know or research that you think's interesting that can add to this. Please set up links. And again, this is just me sharing research and my thoughts on it. And this is not a comprehensive look at all of the science that's available right here. And my closing thoughts on this is that looking at stomach acidity, looking at the digestive tract, sizing, looking at the evolution of humans, I do not feel that the claims that we are species-specific herbivores or frugivores as modern humans is valid. I don't think the science supports it. I think that we have an evolutionary past as frugivores, and that makes fruit very supportive for us as modern humans, but we have a very clear longer history as modern humans being very animal-based focused. So that's my thoughts on this research, and I'm really excited to get into the microbiome.